Hi there, guys. This is Chapter 8 lecture, AP Environmental Science. This one is the chapter where we get into human population, population growth, calculating growth rates. So there's going to be some math in this chapter here. All right. Case study has to do with China. China had a one-child policy. Created a lot of problems for them in China when they had this one-child policy. They had issues with their labor force. They had a bad number or ratio of male to females. It created a lot of problems. The population started getting older. Had a lot of impacts on their actual society as a whole. So what happened in 2013? Excuse me, 2013, they allowed people to have a second child. But certain people were granted permission to do that. Eventually, in 2015, the one-child policy was altered to a two-child policy. All right, they basically figured out that we're not going to shrinking our population isn't really the best idea. If everybody has about two children, that means you're replacing the mating partners basically. So to maintain stability in the size of the population, about two children per household will do that. They realized with one child per household back in the day with the one child policy, they realized that they were having issues. They needed more people to work. They still had quite a few people. People started to age. Imbalances occurred. Males were favored over females because they were a bigger part of the workforce. Created a lot of problems. And you're talking about a country where, as people age, they generally live with their children. And if you have to choose male or female, you're probably going to choose male because he'll have more money in a house for you to live in as you get older. So you're making decisions based on your retirement too. So it's just puts them in a situation that's unfair. Yeah. Our world currently 7.8 billion. That's what it is right now. Your book might say something different. That's because your book is a couple years old. All right. So right now, currently 7.8 billion is the population of the world. You'll notice that places that are staying stagnant, China, I just said about two children per household will keep you stable, and they're expected to stay fairly stable. All right. India, on another look at India here, look at their trajectory. It just keeps going up and up and up, and they're already over a billion. All right. Each one of these is over a billion, and India is growing and growing. You'll notice that countries that have a lot more lower socioeconomic people, or we may call them third world, or we may call them developing, their population sizes grow rapidly. All right, that's one of the characteristics of a developing nation. Okay, so here's the deal. Here's some statistics, and it's talking about exponential growth. First off, all right, um, 88 million people per year are born in the world, basically. It's about the world population right now, right? So about every second, 2.8 people are born. Almost three people every second are born in the world. What's crazy is it took a long time to get to 1 billion, all right? So that year 1800 is when we got about to a billion, all right? And people have been around for a while. If you just want to go back to zero times zero, that means then you can assume time started at year zero, but it didn't. It started before that. You would have it took 18. You would say it took quite a long time to get to 1 billion. All right. Now about every 12 years we add a billion people. So you can say from zero to year 1800 it took to get to a billion. 1800 years you can say to get now every 12 years we add a billion. All right. We learned about exponential growth in another class. It means things are doubling, and you'll see the growth and growth, 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 and boom, it just took off. All right. A big part of this was the agricultural and industrial revolutions. They enabled the world to feed more people. Basically, technology got better, medicine got better. People survived longer than they were having more children. So that's part of the reason why things really took off around 1800. Rule of 70. Now, here's some math we're going to have in this class. We're going to have a little bit of math. I'm going to show you how to work out these problems in a second. Rule of 70 is an interesting rule. Maybe you've ever heard of it. They use this I've heard rule of 68, 69, 70, 71, 72. I heard of it in different ways. It relates to how long it would take something to double. All right, so they use this in investments too. So if you say, for example, I have an investment and it earns 10% interest, and about how long will my money double? How many years will it take to double my money if it's earning this interest? All right. So you can use it that way. You can also use it in population size doubling. So if you know a growth rate, then you can, and if that growth rate stays stable, then you can calculate the doubling time. All right. So here's how it works. It's called the rule of 70. All right. So you start with the number 70, and that would be the number you're going to divide. Okay. So you take 70 and you divide it by a number. The number you divide it by would be the growth rate. Okay. The growth rate. All right. So if the growth rate was 1.2%, okay, and you don't turn that into an actual number 0.012. Nope, you leave it as 1.2%. So you take 70, divide it by the growth rate, the annual growth rate, all right, the percent. You don't turn it into a number. 70 divided by 1.2% would give you 58 years. So if the population grew at 1.2%, it would take 58 years for it to double. Okay, 58 years. China's doubling time prior to the one-child policy, they were having a lot of children. Okay, they were having a lot of children. They had a growth rate of 2.8%. All right, 70 divided by 2.8, they were doubling every 25 years. Okay, just so you know, the population when I was born was around 3.9 billion. Okay, and now it is about double that. Okay, it's about double that. It is double that. Right, 7.8. 3.9 times 2 is 7.8. So when I was born in 1974, so we're talking how many years now? 46 years ago, the population was half the size it is today. All right. So in my lifetime, currently, in my current lifetime, in 46 years, the population has doubled. All right. I was born, it was around 3.9 billion, and now it is 7.8 billion. It's almost exactly double, basically. Here are the kind of problems you're going to get. First kind of problem, the red shows you the work here. If a population doubles in 35 years, what is the growth rate? Okay, so we got to use the rule of 70 here. All right, so we know that it doubles in 35 years. But we don't know the growth rate. So 70 divided by the rate, we don't know the growth rate. X is what we're solving for, will give us 35 years because it says here, doubles in 35. So the rule of 70 gives you the doubling time. In this case, the doubling time is 35 years. We always start with 70 because it's the rule of 70. And in this case, our variable, what we're solving for here, is the rate. Okay, so that's 70 divided by X equals 35. I made this one easy. You would cross multiply and divide, and you would get X equals 2% growth rate. Okay? This problem, a country had a birth rate of 10 per 1,000 in 2010 and a death rate of 4 per 1,000 in the same year. What is the rate of growth for the year 2010? This is a common way birth rates and death rates are given. You're probably noticing currently, you may not have noticed the way they're talking about how many people in a population have the coronavirus, and they give statistics like per 10,000 or per 100,000 or per 1,000 how many cases we have. So there's a common way statistics are given. But they kind of confuse people, so the ideal thing to do is to turn these into percentages. So here's how you do it. Okay, so country had a birth rate of 10 in 1,000, so that's the birth rate. Okay, death rate, which means how many people that are going to be leaving the population. So you subtract 10 over 1,000 minus 4 over 1,000, and that gives you 6 over 1,000. Okay, to turn that into a percentage, you do 6 divided by 1,000 times 100, and that would give you a 0.6% growth rate. Okay, the world's population in 2015 was approximately 6 billion. If the growth rate were 5%, in what year would the world's population be 12 billion? All right, so what we want to know, we're talking about a doubling from 6 to 12, doubling time. So this is rule of 70. The growth rate is 5%. So 70, the rule of 70, divided by the percent. You don't change it into a number. 70 divided, you don't change it into 0.05. Nope, you leave it as 5%. That's how the rule of 70 works. 70 divided by 5 gives you 14. All right. If you ever do a rule of 70 problem and you get like 14.1 will round, or 14.5 would round up, 14.7 would round up, 14.1 you would round down. So if you get a decimal point, you can round. So 70 divided by 5 is 14. All right, 14 years to double, but I don't want to know just 14 years. I want to know what year. So in 2015 plus 14 years, 2029 is the year that this would happen. All right. Number four, a country has a population of 400 million people and has an annual rate of growth of 2.65%. In 1 year, what would the population of this country be? In 2 years, what would the population of this country be, assuming the growth rate did not change? All right, so let's do the first one. These are just throw them into your calculator. Yes, on the AP test, you'll get to use a calculator. So you need to know how to punch these into your calculator correctly. I kept the number simple. 400 million, turn it into a number. 400 million, there it is. The growth rate is 2.65%. There's different ways of doing this. I know some of you are going to take 2.65% of 400 million and then add it back to 400 million. You can do it that way, but I'm showing you the math that eliminates that step. Putting this one in front means you want 100% of that number added to it. So that means you're pretty much doing the step. So this one means 400 million plus 2.65% of it right here. Okay. So 1.02. So to turn this into a number, it's 0.0265. But I want to include the 400 million. That's where the 1 comes in. So 1.0265 times 400 million would give you this number, 410,600,000. So after 1 year, that's what it should be if it's growing at that rate. I want to know in 2 years. So you take this number, 410,600,000, and you multiply it by the same growth rate again, and now you would get 421,480,900. Okay. If I wanted a third year, you would take this number, 421 million, and multiply it by that also, and a fourth year, and so on and so forth. If a city with a population of 180,000 experiences 10,000 births, 20,000 deaths, 2,000 immigrants, 1,000 emigrants within the course of 1 year, what is the net annual percentage growth rate? Well, you got to figure out the number of people you're going to end up extra or less per year. Start with 10,000 births, 20,000 deaths, 2,000 immigrants coming in plus immigrants exiting minus 1,000, and you get negative 9,000. Yeah, a country could have a negative growth rate. That means they're shrinking, basically. Positive growth rate means increasing, negative growth rate means decreasing. So negative 9,000 is the number of people entering or leaving this population. In this case, they're leaving. Negative 9,000, whoops, you divide it by the total population, 180,000, and to turn it into a percentage, you times it by 100, and you would get a negative 5% growth rate. You do need to include the negative to be correct with this problem. All right, so let's talk about some demographics or some statistics that people look at. Infant mortality, all right? This is the deaths that happens to children. Now, frequency means the occurrence of children dying at infancy. Now, countries that have good technology, good medicine, infant mortality is very low. Poverty, even in a country like the United States where you might have poverty in areas, poverty, low socioeconomics, areas like that have a high infant mortality. Okay, so what has brought infant mortality down? Well, people are living longer worldwide, and that's because medicine's gotten better. I mean, antibiotics are more available where they weren't. In general, sanitation, people are, society has gotten a little bit better at cleaning itself up, so to speak. There's more food being produced. All right, so there's better nutrition. A lot of things have brought infant mortality down, but generally, um, more low socioeconomic developing nations, third world countries we may call them, or developing nations, they have higher infant mortalities than first world or developed nations. And by the way, high birth rate was very important early on. It was very important because since a lot of children died, you wanted to ensure that you had children to take care of you one day if you were going to retire. Yeah. And you needed them to help you work. All right. Um, Thomas Malthus predicted that we were going to run out of food. We were going to have problems. But what have we done as a society? Well, we've gotten smarter. We grow food at a much more rapid rate. Okay. We've slowed birth rates down. We're not growing as rapidly as we used to. The population is still growing very rapidly, but a lot of countries have done a good job at slowing the birth rate. We're going to talk about what would slow down the birth rate too later in this lecture. All right. Now, there's a model that's been created to calculate impact, all right? Impact on an environment. And what would create impact on an environment? Well, there's several factors that create impact on an environment. First one is the number of people, population, okay? How many people you have, more people you have, the bigger impact it has on the environment. The second one, affluence. This has to do with how much money, affluence, how much cash you're spending. More money you spend, the more resource consumption we're going to have. So this right here has to do with money. All right. Per capita means per household or per individual in some cases. Sometimes the household is an individual. So you're spending money here. This has to do with money. The more money people spend, the bigger impact it has on the environment. All right. That's well known. So we talked about our ecological footprint. Yeah, we have a big footprint in the United States. We have a large per capita. We spend a lot of money in our country. Third world countries where there's lower socioeconomics, they're not spending as much money. Their impact is lower on the environment. T stands for technology. Basically, to have technology, you need resources, and you're exploiting resources. It means you got to go get them. You need to mine for things generally to get those types of resources. So another large impact on the environment. So population, people, money, how much money people are spending, affluence, technology, resource. This is resource consumption, but more of resource extraction and resource exploitation. There's also another factor that's added to sometimes, and it's called the S or the sensitivity factor. That's because some areas, they're more vulnerable. They can be impacted greater by some of these things. And so you have to include a sensitivity factor. So then overall, you're going to get an impact value, like how bad it affects an area. All right. Okay. Demography. Demography is the study of the human population. And what are you studying? Size, distribution, age structure, how many males and females you have, birth rate, death rate, emigration, immigration. Okay. This is one of those statistics they take when you fill out an application for something. They ask you all kinds of things about yourself, like your national origin, like a country of origin, where are you from, or for example, they might ask you your age, your birth, where you were born. They're just asking you tons of questions. So they're basically putting together statistics and demographics of a society. All right. Just like organisms in nature, populations generally are clumped. They go to where they have the most resources. And you notice here, look, India over here is pretty crowded. China over here is really crowded. Some of these islands over here are crowded. You have some areas over here that are crowded. In the U.S., they call it an East Coast bias. Well, where do we have more people in the East Coast? There's why it's an East Coast bias. You don't have people are very like not very they're very spread out in this part of the country. All right. If you'll notice there, as you go really north, you don't see as many people. Okay. Or really south, you start losing. So what happens? People go where there's more resources, where there's more climate's better, where there's more food, where there's the ability to grow food, farming. Those are all factors. So generally, equatorial areas in these areas here, and these basically these areas that aren't excessively hot, also around. Look where we're at in San Diego over here. Not very dense. Part of the reason why we didn't have a crazy problem, particularly as other places like in the East Coast with the coronavirus. Now, these are population pyramids. You need to be able to read them. They're telling you about demographics. They can tell you about a society and they can help you make interpretations about a society. All right. So if you see a pyramid like this, we're going to talk about what this means. We're going to talk about what this pyramid means and what this pyramid means. Okay. They allow us to predict future growth. All right. So when you see a pyramid that looks truly like a pyramid, you're generally talking about a third world country here. This is not a developed nation. People are having lots of babies. Why are they having lots of babies? Because maybe a lot of them don't live very long sometimes. Another reason is they're in a developing nation where there isn't a social security system in place or a retirement system in place. So people elderly depend on the younger generations for help. For basically they live with each other. They don't go live in a nursing home like they do in the United States. So this would be a third world country, generally from a lower socioeconomic society, a developing nation right here. And this is showing you a population boom. It's growing very rapidly. Okay, when you have it fairly, straight, not so much of a pyramid. This is stability, population stability. Okay, Generally speaking, it's for the most part, it's each age group has about the same percentage of people in it. So this would be stability, right? When you start seeing this part here, this narrowing at the bottom, people are having less children. Okay, people are having less children now. A lot of countries, you should see this type of pyramid, but they don't always have this type of pyramid. And let me give you an example why. Emigration and immigration would put people in the society, but they wouldn't necessarily, they would be entering the country, so you may not see them as births. So you could have a country that should technically have this kind of pyramid, but they don't. They have more of a pyramid that looks like this or even this, and that's because of immigration. People are entering the country, they want to be there. Okay. I've already, all this is explaining everything that we're talking about here. All right. This is back again. This is explaining a lot of what I've said. So expect a lot of growth, expect a population staying relatively the same, and expect a population that's shrinking. All right. This is showing you, I believe this is China. This is China 1970s pyramid and 2014's pyramid. And you'll notice in 1970 what was going on. They were growing pretty rapidly. Okay, they were a pyramid. And now you'll see 2014's pyramid, it's gotten more stable. So it's just showing you how their population has shifted. And because of those policies that they created with the one child policy and now the two child policy. Okay, so these are called. These also are called sex ratios. All right, so males to females. It's another term you may see. All right, and this is showing you China in 1970, like a true pyramid. In 2015, kind of stable. We have some bulging areas here. Okay, some bulging areas that took place here. And then in 2050, you're seeing more stability, even a little bit of potential of shrinking, but for the most part, I believe it's staying stable now. This is projected, by the way. Okay. And population, we just talked about it. Births, deaths, immigration, emigration. That was the math problems that we just did. And this is showing you infant mortality around the world. You look at the U.S., you would think we would be the top. We would be the darkest blue. But we're not, and that's because we do have a lot of people in our country who live at a lower socioeconomic level. They don't necessarily go to the hospital when needed, because they don't have insurance. They don't go get treated, consistently. They're not going in and getting checkups, so their health might be and they're not eating as well, so their health is generally not as good. Okay, so we're not the top. We're not the best, so to speak. All right, Canada has a lower infant mortality than we do, but they probably have less poverty in their country. Okay. Um, okay. So basically, death rates have gone down. They've gone down. Okay. And immigration. I said this significant impact on countries like the United States. People in our country are not having as many kids as they used to. They're not. But do we have people entering our country? Yes, we do. All right. We're going to stop there.